Find the square root of negative 5 minus 6i so that the real part of your answer is positive. Now there are two ways to do this. Let me first show you the polar form using the polar form way, because this will give you the answer quicker, at least if you want to get a approximate answer. So what's a polar form? Well, if you represent this negative 5 minus 6i on the number line, the complex plane, you have negative 5 and negative 6i. So this point is what we will call the negative 5 minus 6i. Well, we're saying something squared gives you this. So and because in polar form, two numbers multiply in a way that you have r1 angle theta 1 and r2 angle theta 2 equals to r1 times r2 angle of theta 1 plus theta 2. And what's important is that the two angles add up. So if you had any number in polar form and you squared it, it's going to be r squared angle 2 theta. This is also called the de Moivre's theorem. So this says that whatever that number is, if it became, let's say this number became negative 5 minus 6i, then your previous number that's squared to get this one would have had half the angle. So it must have been an angle half of this angle. So you can kind of think of somewhere here. Well, it should be of a smaller size because the length gets squared. So it must be somewhere here. But this is not what we want, because we want the real part of the answer to be positive. Therefore, what we need to do is to get another one, and actually there's another. See, if you think about this angle not as a positive angle but as a negative angle, then the square root of this would give you something in here. And this number, I don't know exactly what's the magnitude, but whatever that number is, that's going to have the real part to be positive, right? So I guess what we want to do is we want to represent negative 5 minus 6i as some magnitude and angle, but I want the angle to be represented as something between less than 0 and bigger than negative 180 degrees. That's what I want, so that I'll get the negative version. And if I have the negative version, then I can take the half of it, and that angle will give me a complex number that's on the positive side of the real part. Okay, so let's do that. We're going to use the formulas. The first formula is r is equal to square root of each of these squared. And one very important thing is you should never put I into this formula, because I've seen so many people making that mistake, putting an I inside here. You only take the coefficient of I. You don't take the negative 6i, you put negative 6. And if you do that, you get square root of 25 plus 36, which is 61 square root. Okay. On the other hand, the angle theta would be tangent inverse of b over a. Once again, b is this, a is this. So you have negative 6 over negative 5. You never include the I in these formulas, okay? And then you have to put some modification here. You have to add or subtract some numbers, some angles sometimes. And that depends on the following convention. If you have anything on the right side, you don't have to modify, but the tangent inverse has a blind spot. It doesn't give you the correct answer if your number falls in the left side. So if it's on the second quadrant, you should be adding 180 degrees, whereas if it's in the third quadrant, no, yeah, third quadrant, you should subtract 180 degrees. Okay, so since our number is in the third quadrant, this is in the third quadrant, we should be subtracting 180 degrees from the tangent inverse. So what we need to do is tangent inverse, negative negative cancel, so it's 6 over 5, which is 1.2, or 6.5, 6 over 5 is still okay, and minus 180 degrees. And we have to figure this out by using a calculator to find it. So let me use a calculator. So I want tangent inverse of 1.2, and I have it as in degree mode because I'm subtracting 180 degrees. You could also put this in radian mode and subtract pi instead, but for me this is less confusing, so I'll do that. Okay, so that's good. So we have this as the angle. Keep in mind that this is in degrees. Okay, so that's what we have as degrees. And what's square root of 61? Square root of 61, SQRT of 61 is this number. Copy, and then let me put it here. This number should come right here. Okay. And then that's what we have. All right, so let's just briefly copy this to the next slide so we can continue our calculation. So it's this one, and then this one. Okay, so what do we know so far? We know that negative 5 minus 6i in polar form is r value being this and the angle being negative 129.80 something something degrees. Okay, so if I take the half of this, so if I take the 1/2 power of this, that means I'm taking the half power of this, which means I'm taking the half power of this, and I'm taking half of that. Over 2. And the reason I'm using this is I'm just using the de Moivre's formula, which is r angle theta to the nth power is r to the n angle n theta, right? And this is supposed to be used for only integers, but if it's not an integer, then you have to be careful because it, like say a square root, you have more than one answer, right? So this formula, when applied to a fraction, will only give you one of the possible answers, but since this answer indeed gives us the answer with the positive real part, well, this will be, overall, this will be in the fourth quadrant, which has the positive real part. This is indeed the one that I want, okay? And by the way, since this is degrees, you should definitely put a small circle there to represent degrees, okay? Okay, so what is that? Let's try to calculate that. First, what's the square root of 61? So let's try that. Take the square root of square root of 61. Okay, and that's 2 point this number here. And then the next number is we have to take this number here and divide it by 2. Divided by 2, which is 64 point something something. Okay, and that's a minus, so let's put a minus here. Angle degrees, and now we have to convert this back into the rectangular form, because the original question was given in a rectangular form. So what you need to do is you have to use the fact that r angle theta is really a shorthand for r times cosine theta plus I times sine theta, right? So let's apply that. So we are going to do, let's first do r cosine theta. So I know this is 4th root of 61, but this one I can't memorize, so I'm going to put that into the calculator. So what I'm going to do is I'm going to take 61. I'm going to take 61 to the power of 0.25, because that's 1/4 power, okay? Times cosine of the angle I just had, and that's the value for the x. Okay. On the other hand, I need to do the sine this time, so let's put the, let's copy this, delete this, now use sine. Okay, and in that case you get, well, actually it should be minus, I forgot about the minus sign. So because of the minus sign, it's negative, and this is the imaginary part, so I should putting a I in there. Okay, so there you have it, that's the answer. Okay, so that's how you do it with the polar form. Maybe those calculators going back and forth may have been confusing, but really this I think is the better method. But just in case, if you want another method, let me show you this other method. You can just set x plus yi as the square root of -5 minus 6i, meaning that this is a number whose square is equal to this. Well, if you FOIL this out, what do you get? You get x times x, x squared, x times yi, x yi, y times x, so again x yi times yi, that's y squared, I squared, but I squared is -1, so you get x squared minus y squared, -1 y squared, and then these two are like terms, so they add up to give you 2xyi. And we're trying to make this equal to -5 minus 6i. So what does that mean? That means we get a system which says x squared minus y squared should be the -5, the real part, and 2xy, which is the imaginary part, should equal to the imaginary part. Now furthermore, we have to make an agreement that your x and y are reals, because or else if you let y to be complex, then this you can't write a complex number uniquely. Any complex number can be written as x plus yi with x and y to be real numbers. Okay, so that's something that I should have said even before beginning, but that's what we have. We have this system of equations, and look at this. Although it looks complicated, you have two unknowns, x and y, and you have two equations, which is a good thing. It means that you can solve it. Now, to solve equations like this, you first solve for one of the variables. Let me solve this for y. So y is equal to -6 over 2x. So you have -3 over x after reducing 6 and 2. And that can be plugged in into y here, because that's y, right? So the resulting equation is then you get x squared minus -3 over x squared equals to -5, and x squared minus 9 over x squared equals to negative 5. And whenever I have a fraction, I can just multiply by x squared the denominator to get rid of the denominator. X squared times x squared is x to the 4th. 9 over x squared times x squared. The denominators get cancelled. And finally, you get negative 5x squared. Move it to the left side, and you get x to the 4th plus 5x minus 9 equal to 0. And this is really a quadratic equation in x squared form, right? So you can solve for x squared. I mean, if you can't see that it's a quadratic equation in x squared, you can also try doing substitution. U equals x squared. That gives you u squared plus 5u minus 9 equal to 0, right? So it is a quadratic equation, and the solution would be that x squared equals to x equals to negative b, negative 5 plus minus, and then square root 5 squared minus 4 times 1 times 9, 4ac, all over 2a, and a is 1, so that's what you get. And since x is real, and therefore x squared must be positive or 0, so the minus 1 is negative and negative. That's no good, okay? So we can't use that. Oh, by the way, this is negative 9. And then so we're only going to take the positive one, and that will be negative 5 plus square root of 25. Negative negative becomes positive, so it will be 4 times 9, which is 36, over 2, which is negative 5 plus square root of 61 over 2. That's your x squared. So x must be plus or minus the square root of this thing. But because we agreed that we're looking for only the positive x, or a positive real part, we're just going to scratch the plus minus and only take the positive one. Okay, that's a start. We know now what x is, right? Now we have to figure out what y is. Y would be, well, if you go back, it's negative 3 over x, right? So symbolically it should be just negative 3 over square root of negative 5 plus radical 61 over 2. So that's it. Therefore, the answer must be square root of negative 5 plus radical 61 over 2 minus 3 over square root of negative 5 plus square root of 61 over 2i. And then we can use the calculator to actually compute these, and you'll find it to be exactly the same as what we got in the previous one. Since I think we've done enough calculators, I think this should be a good place to stop.